Hi, I'm Tanner Zhang. I'm a physician scientist and a data engineer at Johns Hopkins, and I work on a problem most people never see. When a hospital sends a clinical document and someone wants to actually analyze it, the document has to change shape. It has to come from the standard it was sent in into the model we do research on. A lot of information gets lost in that crossing, and nobody was actually recording it. The project measures the loss and then closes most of it safely. Two pieces, both on fully publicly available data. So here is why I care. The whole field is moving toward linking data, claims, plus documents, plus registries, plus device and molecular data, all put into one analytic model so we can ask real analytic question. The model is usually OMOP, one of the most popular ones, but the data doesn't arrive in OMOP. It arrives in HL7, in CCDA, in FHIR, and in V2, which is still what we most lab reporting and surveillance runs on in this country. So every ambitious linkage quietly rests on one boring step. Does the coded content survive the trip from the exchange standard into the analytic model? Often it doesn't. Our pipelines weld parsing and mapping and routing into one move. So when a code has no home in OMAP, it doesn't throw any error, it just vanishes. No log, no warning, and every code that vanishes is a clinical fact we will never be able to analyze. That bothers me, so we measure it. I want to be honest with this room because you have seen a lot of large language model maps codes talks. Using a large language model to map the OMAP is a crowded space. CDE mapper Adams and colleagues with a tiered embedding mapper and colleagues with a hallucination prevention one and other people on constraint decoding. So I am not going to stand here and claim I invented the mapping. What is new here is narrower, and I think it is a part that really matters. We lead a coverage map, so we only span the model where there is genuinely no deterministic answer. We make it target aware. The model OMAP can only choose from the legal targets of the destination fields. We treat I don't know as a real measured answer, and we grade every mapping honestly, so a close enough match never gets dressed up as an exact one. The combination on the hot part is a contribution. So here is a machine. And the one idea to hold on to this is this. The ontology bounds the model. We don't ask the model to be trustworthy. We build a box so it cannot lie inside of it. Is step one, the coverage map sorts every code against OMAP. Step two, for each hard code, we build a target aware pool, only concepts in the target domain only standard concepts, only for that CDM field. Step 3, we retrieve candidates with a biomedical embedding model. Step 4, and this is the safety hinge. The model proposes by picking an index from a fixed list. It cannot type a concept ID that doesn't exist. Step 5, a separate model. It's a large language model judge. Checks that pick against the actual definitions. Step 6, if it isn't confident, it abstains, and whatever it does map comes out of as sesame with its reason attached. 2 to 4 cents a code. The whole run costs about $35. This is the first deliverable, and it is the one I would frame on a wall. Across 119 value sets and almost 400,000 codes. 88.5 is fine, it's already standard or grouper, or it has exactly one deterministic target. No AI needed. And I want to be clear about this part because a lot of this field spends a model on codes that don't need one. Then the 10.1% is the residual codes that are in OMAP but with no single answer, the one to multiple mappings. And 0.7% is absent from OMAP entirely. The last silver has no deterministic recourse of any kind, and that's the slice we went after. Before this map, none of that was a number. It was a shrug. So here is a member working the hardest codes. The 1841 with no OMAP concepts at all. It saves 1344 of them, about 73 of them. And the part I'm proud of isn't that number, it is the 500 it refused. It handed those back instead of guessing. The ring of the right is the honesty. Around 1000 are true exact matches, and the rest are graded broad, close, or narrow. Because a surrogate is not an equivalence, and I won't let it pretend to be one. An independent audit checked all 1344 and found zero that broke the pool constraint. Every target was domain corrected and standard. So here is what the output actually look like, and it is where the honesty lives. Every mapping ships as system with a predicate that says how good it actually is. Top row inpatient encounter to inpatient visit. That's a true exact match. Confidence 0.97, no argument. Middle row, the trauma critical care to intensive care. That is not the same thing. Intensive care is broader. It loses the trauma specificity, so it is a broad match, and it says so. The bottom row is another example. So the distinction is the whole point. A lot of members would call all three of these a match and move on. We don't, because a downstream researcher needs to be able to be filter on it. So if you want true equivalences, you can have them. And if you accept broader or narrower surrogate, that's your call to make, not ours to hide. And the system would be the key piece to make all these mappings reusable. As we all know, the manual mappings are pretty expensive and labor intensive. So the reusability and the shareability of the mappings is a key part for us to work in the whole vocabulary society. A number is only worth something if the test was fair. So we didn't grade our own homework. We built a goal set of 7,000 items by taking codes where OMAP already knows the answer, hiding that answer, and ask the system to recover it. It never appears in any prompt. A keyword baseline gets it right about half of the time. Our re-ranker gets to 0.37. 71, which declining on the 70 percent is unsure of. And when it does answer, it's right 80%, over 80%, which is 85% of all the time. It is also calibrated. The ECE is 0.038, which is what makes the abstention trustworthy instead of theater. And I will say the honest part out loud. We measure accuracy on the codes where a ground truth exists, and we deploy on the codes where none does. That's not a dodge, it's forced, and it is why the condition review matters as much as the benchmark. The key piece here is the human never leaves the loop. We as clinicians are the guardrails of this one. So if a reviewer only remembers one slide. I want this to be the one. Same model, same prompts, run two ways. Turn off the target-aware constraint and 11.4% of the picks land in the wrong domain. A visit concept where a unit belongs. Turn it on and that's zero, not lower, zero by construction. So the safety here does not come from a bigger, smarter model. It comes from the symbolic box we put around it. That's a whole thesis in one chart. So here is a clinician's verdict. Accuracy on benchmark is one thing. A clinician calling it safe is another. And that's a bar that matters. And why this matter beyond our demo is the finding I want to leave with HL7. All these codes, they all have a OMAP home, and the member retargets the whole OMAP-based platform. It's a reusable bridge, the same between how we move data and how we analyze it, which is exactly the same that the multimodal linkage we runs on. So 3 sentences to take with you. Measure the gap, feel only the residual, never guess. We built a reproducible coverage map, a mapper that recovers 73% of the codes with no OMAP home at all, and the connection signed off 95.6% with zero safety flags, and a real bridge from HL7 exchange standards into the analytic model that the common data model actually needs. The code and a one command rebuild are in the repo on the screen. Thank you to Emily Pfaff and Chris Schut for the guidance, and to Alison Anderson for the technical review. Thank you.